First of all, thank you very much for joining. I just see a participant count, but I'm hoping that you're all listening and all ready for the next talk. So what I want to talk to you about in this talk is about Hyperloop, and I will first start by giving you a general idea of what Hyperloop is, how Hyperloop came about, what the main ideas behind it are, and then talk a little bit more in depth about what we are doing here in Munich. But I want to use that as an example of all the things that are going on in the Hyperloop community all over the world. So to me, shortly, my name is Gabriele Semino. I am the project lead of the TUM Hyperloop project at the Technical University of Munich, and I'm also the chairman of a non-profit organization that is pushing the Hyperloop idea in particular. And to start off the topic of Hyperloop, I want to first discuss how we are traveling today and a little bit about why it matters. And I want to start by doing this by just mentioning a couple of numbers, which are this is the typical way you start a presentation about transportation. And the numbers that you see here are in particular from the European Union, and I want to stress that those are before the COVID pandemic. But since we're looking very far into the future, it's hard to now predict how much the COVID pandemic will have effects in 20 to 30 years. So I'll still mention those numbers. But one of them, and I think it was mentioned also in the previous talk, is that transportation plays an important role in the amount of carbon emissions or greenhouse emissions that we have in general. These are the numbers again from the European Union at 24% currently, and we quickly need to get that down. And also, but if we look at the current transportation system, we see that projected to 2040, we will have a surplus demand for transportation by aircraft of around 8% of the capacity. So that is something that needs to be addressed, and that current aircraft technologies doesn't deliver a good alternative to in terms of a sustainable solution to that and a zero emission solution to that. We've heard about ideas, but we need to look at a very different alternatives and very different platforms to try to find solution. And also we know that despite the current hiccup with the hopefully just a hiccup with the COVID-19 pandemic, we generally have seen for many years, and we probably will keep seeing after we can get over the pandemic, that there will be an increased demand for passenger transport, but also cargo transport, and that's clearly something that we need to address. And you see the percentages on the screen; those is a very huge demand increase that we're expecting. But also taking it from another perspective, and I want to start with an example here. And I don't know how many of you here listening are from Germany or know Germany pretty well, but I'll take an example from Germany since I'm living in Munich, and it might happen, maybe not around this time, but before, it happened relatively often that I had to go to Berlin, and Munich to Berlin is around 600 kilometers on the road, so it's a medium distance for aircraft. And so there are a couple of options if I want to go to Berlin starting from Munich. The most obvious one, at least from a German perspective, as we tend to like cars quite a lot, is to drive by car. It takes around 6 hours to drive the 600 kilometer of Autobahn between Munich and Berlin. And if I'm assuming that I need to drive alone from Munich to Berlin, then that's results in a pretty high carbon footprint resulting from my travel. But the main advantage of the car, and one of the reasons many people still choose to drive by car, is that you have the highest flexibility you can get. You can hop in the car whenever you want, you can start driving, you can get there. And given that Autobahn is free in Germany, and the price of oil is not all too high, even if you're driving alone, the price is relatively low driving by car. So driving by car clearly takes some time, but you can get there you can definitely get there and you have pretty high flexibility. The alternative is obviously to try to use the train. There is a new train connection that has been there for a couple of years now between Munich and Berlin in particular, that brought down the time from 6 hours to 4 hours, meaning that you are 2 hours faster than by car, your carbon footprint is obviously way lower with the electric trains that we have. But you have pretty low flexibility in the sense that you can get to the station and you need to wait for a train, which doesn't come all the time. Obviously, there's I think 1 every 2 hours or something like that, 1 every hour, and in the morning and in the evening, probably from Munich to Berlin. And depending on when you want to hop on a train and go to Berlin, the price can be pretty high. If you want to book on the last moment, it can get pretty expensive. The alternative that before this new train track I mentioned was pretty popular is to go by plane. And while the flight itself takes roughly 45 minutes, I think, from takeoff to landing, the total journey, if you start from city center to city center, is way longer. It takes some time to get to the city center to the airport and back. You have security checks, you have to wait for boarding and everything. So the travel time is pretty long. And obviously aircrafts, at least with the current technologies, are known for their pretty high carbon footprint. And again, this flexibility is limited in the sense that I can get to the airport and try to hop on a flight, but again, this doesn't come all the time. And the price, again, in particular, if I want to go quickly or I want to take the next plane, it can be pretty high. So as I mentioned earlier, three modes of transportation, all with different pros and cons, but the idea of Hyperloop, and that's what I'm getting at, is to find a sweet spot in the middle for this middle-long journey. So the idea of the Hyperloop would be to have a travel time of less than an hour. So by connecting city center to city center at very high speed, have a lower carbon footprint than current trains, so very, very low compared to all the other modes of transport, to have a high flexibility by having relatively small vehicles traveling, like starting repeatedly from the city, and have a price that is comparable to, or very competitive compared to trains and aircraft, and possibly comparable to a car. And as I mentioned, this is where Hyperloop comes in. And I want to spend a couple of moments talking about Hyperloop and how we got started with the Hyperloop idea and how it got started actually, and how the environment of Hyperloop is developing. So the Hyperloop name was let's say, started or developed by Elon Musk in 2013 when he presented the Hyperloop white paper, presenting the Hyperloop Alpha concept. This white paper started a whole movement around Hyperloop, and in particular, he presented a concept, so roughly a combination of technologies that he thought would allow to use this to find a better system for the sweet spot. So these 600, let's say roughly 300 to 2,000 kilometers distances between cities that need a high, that people want to travel from very, very fast. And in this white paper, he presented the idea of Hyperloop, which is roughly presented here. The idea is to have a very low emission, or better zero emission transportation system, which can therefore be considered pretty sustainable. We're at very, very high speed. So it suggested speeds up to the speed of sound, which would be 1,200. But in principle, everything above 900 kilometers per hour can be comparable with aircraft speed while moving on the ground inside pressurized tubes that contain a vacuum and therefore have very low drag and therefore allow very high speeds. And to do that, you need magnetic levitation and propulsion to move contactless on this track. And if you look at a typical image of how this could look like, you generally see this kind of renderings. You see this tube again that is used to preserve a vacuum in there, and then have these pods that travel at very high speed through the tube. And as I mentioned, the idea of Hyperloop started in 2013 when Elon Musk presented this paper. And one particular thing that Elon Musk did is that he open sourced the idea, in the sense that he said, I'm not using that for a company in particular. I would like the general public, the community, the startup community, and research to develop this idea and to make this idea into reality. And then one thing that he did a couple of years later, starting 2015, was to start a competition which became known as the SpaceX Hyperloop Pod competition, which allowed an even larger group of people to start working on this idea. And the general idea of the competition was pretty simple. So if you look at the very right of this image, you see a tube that is on a street in Los Angeles, and that is the test track in principle for throughout the competition. And then the invitation went out to teams all over the world to build their own pod prototypes and to bring them to LA roughly once a year, and then test them in the tube. And if a couple of you maybe can have a look at the picture, you might recognize a German flag there, and that's where then I'll go to what we are doing here in Munich. But before I start with that, I have a short video presenting the competition and what and general idea behind it. You might recognize the voice of the person speaking.
What this competition is about is encouraging people to think about new modes of transport, things that could radically transform cities and the way people get around. And what you're working on is the only thing I'm aware of that could actually be a radical improvement of this current state of the art.
The loop is currently pumping down. The team is doing their final countdown once more. Everything looks good to go.
5, 4, 3, 2, 1.
So perfect. So this is kind of gives you an idea of what the competition, and the competition was really a driver and a catalyst for a lot of teams all over the world starting to work on the Hyperloop idea. Obviously, I'll take my team and what we're doing here in Munich as an example of one of these activities that really started focusing on Hyperloop and start developing Hyperloop prototypes. The competition really delivered the platform. What you can see here is one of our latest prototypes that took part in the SpaceX Hyperloop pod competition. The competition was actually really focusing on speed. So speed was one of the crucial aspects of the Hyperloop, and something that we really got to work on a lot while working on the competition. If you look at our last pods, and I'm sorry about the artifact around the second image, but we really got to improve our speed from year to year, again pushing what the goal of the competition was to improve the speed. But if you look at the general at what happened in general over the couple of years, here in Munich, it got really as a chance to improve from year to year and to develop Hyperloop technology. So if you look, we started around 2015 to develop Hyperloop prototypes, and the competition was organized till 2019. And in that time frame, we really were able to step up from year to year our game in terms of speed, and also doing that by reducing the pod mass and improving power density. And what I'm really proud of is that the team here in Munich was able to win every competition with the fastest prototype in the race from 2017 first competition till throughout 2019, which is something that really speaks for the team, the group behind me that's really pushing the Hyperloop idea here in Munich. And one thing is obviously the competition, and that is something that we've really taken part on and we're really proud of. But another thing that we've been focusing on is all the other aspects that are needed for the Hyperloop behind speed. And one thing, for instance, that we try to push is the idea of developing a full-scale system and a complete integrated system. So what you see here is the first attempt that we built last year actually, which is a small scale complete Hyperloop system. So in principle, different levitation and propulsion mechanisms are integrated inside this small diameter tube that really allowed us to test some key technologies and to learn about different aspects, in particular also about the vacuum, which is a crucial component of the Hyperloop. So as I mentioned, the competition delivered as a platform to really start developing this technology, and the same way it did for us, did for a lot of other teams around the world, and also in particular motivated a large number of young people. Before I close this topic, however, I want to give you a little hint about what is to come here in Munich and in general. So the competition has again delivered this awesome platform to start developing the Hyperloop, but we're by far not done there, and actually there's going to take way more time and years to develop the Hyperloop, and a lot of effort from the public and the private sector. We were, as I mentioned, started here at the Technical University of Munich, and the Technical University of Munich has really picked up on this Hyperloop idea and is increasing its steps. So what we really want to do here is from a research perspective, from a university perspective, deliver the basis and foundation to really develop the Hyperloop system. There are a set of companies that are marketing and are developing the Hyperloop technology, but there is an important step there that also the public sector and the university needs to step in. And I'm very proud that the Technical University of Munich is allowing that. We're really coming together, the University of Munich, the Bavarian government here, the local government, and also a lot of partners from industry really came together here to start this the Hyperloop program here at the Technical University of Munich. And as you can imagine, there is a lot of things that need to come together in order to develop a complex system like the Hyperloop. What we're doing here is, on one side, obviously technology development, which means developing the different components, but this comes also with other aspects, such as simulation modeling is crucial in order to get there. We need to do feasibility study in order to understand where the market lies for Hyperloop and where applications might be. And finally, which is something that is often mentioned, often criticized about Hyperloop, we need to take a deep look into safety aspects and make sure that not only we have some technology that works, but we have some a safe technology to transport people. And one thing in particular where we want to integrate that, and I'm just mentioning that, and then I'm closing my topic, is developing demonstrators, which in principle allow us to put all these technologies together and see how they work and whether their functioning is also as safe as expected. So this is something, the project we're currently working on, then is going to be presented at the end of next year, which is a 24-meter tube with a full-scale passenger pod in there, not going for small scale anymore, but really full scale this time around to test all these technologies. And with that, thank you very much for listening. I don't know if I have any time left for questions. I don't know if there are any questions. No, I was told to wrap up, so that's it. Thank you very much.